Good morning friends. Today we are here for your unit number 4, that is polyphase AC circuit, first part of unit 4. So previously we had studied about the generation of single phase AC supply by elementary alternator method. Now we are going to generate 3-phase AC supply. So we are going to use the armature windings and we are going to divide the windings into 3 different sections for separate AC voltage which will be induced against each of them. So there are many independent AC voltages present which is equal to the number of phase of the windings. So various phases are arranged such that the magnitude and frequency of all the voltages are going to remain the same and they have definite phase difference with respect to each other. So if I consider n number of phases, so I can have same magnitude and frequency of that n number of voltages and there will be a phase difference that will be 360 divided by n in between each of them. So if we have a 3-phase system, 3 voltages, they are going to have the same magnitude and frequency and the phase difference will be 360 divided by in place of n 3, that is 120 degrees. So such supply is called as 3-phase supply system. Then let us go through the advantages of 3-phase supply system. The power output of 3-phase machines is greater, we can say 1.5 times that of your single phase machine. For transmission and distribution, the 3-phase supply, it requires less copper, so it is economical. Then it is possible to generate rotating magnetic field in your 3-phase system and therefore the 3-phase motors are self-starting. Then the 3-phase system, it gives steady output. There are less power fluctuations as compared to single phase, and you can obtain a single phase supply from 3-phase system. The power factor cos phi term of your single phase motor, it is poor than your 3-phase, and you can say the 3-phase machines are smaller in size and also they are cheaper and less expensive than that of the single phase machines. Now let us check how to generate a 3-phase supply. Okay, so for generation of single phase supply, we had taken single phase armature winding, and to that armature winding we had rotated that armature winding in a magnetic field. So similarly, for 3-phase supply, we are going to take the armature windings in 3 different groups: R1, R2, that will be first group of winding. Then you are having Y1, Y2 and B1, B2. So voltage across each phase or each coil, you can say, that is across R it will be ER, across Y EY and across B EB. So these ER, EY and EB, they are having same magnitude and frequency and they are displaced from each other at 120 degrees. That was 360 divided by 3, 120. So ER, we are going to assume it as a reference. So it is going to start from 0 and at 2 pi. EY, it will be displaced or it will lag ER by 120, and EB, it is going to lag ER by 240. So standard equation we know for voltage, that is V is equal to Vm sin omega t. So similarly, ER will be equal to Em sin omega t for your R phase, Em sin omega t minus 120 for Y phase, and Em sin omega t minus 240 for your B phase. So now if I want to draw a phasor diagram for my R, Y and B voltages, I can say ER on my reference axis, it is having a phase difference of 120 with respect to EY. So you can have EY is lagging ER by 120, and then after 120 degrees angle from EY but 240 degrees angle from ER, that will be your EB. So EB will lag EY by 120 and EB will lag ER by 240, and we can say the vector addition of all the voltages will be equal to 0.